My name's Alexa Rich.
I'm Alexa Pena-Whalen.
I'm Paola Vargas.
I'm Nikki Hoffman, and this is our final proposal for our Milestone project.
We chose to research the grand challenge of reverse engineering the brain. Dementia is a condition we found interesting to figure out a cost-effective prevention method for. The NeuroCleanse patch is the solution we came to. The NeuroCleanse patch is an affordable, reusable, and non-invasive patch that uses a small ultrasound emitter and EEG sensors to detect deep sleep and send targeted sound waves, which stimulates the brain's lymphatic system to clear harmful proteins like amyloid. By slowing down memory loss, the patch provides a cost-effective alternative to expensive drug therapies, which makes treatment more accessible for low-income patients.
The NeuroCleanse patch is designed to make the lymphatic system more efficient. The lymphatic system is the brain's primary waste clearing tool, which is most active during deep sleep. The goal is to slow down the decline of brain function that is related to dementia. This patch is basically reverse engineering the brain's natural cleaning processes. The patch uses EEG sensors to read brain waves that determine when the user is in a deep sleep. This helps to make sure the process is occurring at the perfect time to maximize the effectiveness. The disposable part of the patch contains bioadhesive hydrogel, which has two important functions. It holds the patch in place with sticky bioadhesive, and it provides the electrical conductivity that is needed for the EEG sensors to read the brainwaves. Once the patch senses deep sleep, the low-power ultrasound emitter sends gentle and harmless sound waves out. These sound waves are scientifically supported to help the brain generate gamma waves. These gamma waves release vasoactive intestinal peptide, also known as VIP, which instructs astrocytes, which are support cells in the brain, to expand the spaces around blood vessels. This expansion helps to improve the efficiency of the lymphatic system, which helps to accelerate the removal of harmful proteins like amyloid. This will help the nerve cells function better and help to decrease memory loss that is associated with dementia. I will be explaining each piece of our main visual. The process starts with the disposable patch, which contains the piece that sticks to the skin using bioadhesive hydrogel and the EEG electrodes. The hydrogel has two functions. It secures the patch with the adhesive, and it provides the electrical conductivity for the EEG electrodes to read the electrical signals, which are your brainwaves. The reusable puck contains the rechargeable battery and the printed circuit board. The ASIC and the DSP chip unit on the printed circuit board control the whole process. This unit is very important because it processes the EEG signals to detect deep sleep, and it also controls the low-power ultrasound emitter by determining the exact timing and frequency output of the sound waves. Next is the low-power ultrasound emitter. It activates once the DSP confirms deep sleep. It sends gentle specific sound waves to produce gamma waves, which help to chemically boost the lymphatic system to accelerate clearing harmful proteins like amyloid.
Our target audience is the elderly population in Bertie County, North Carolina. About 16.6% of the target audience are living with dementia. The average household income is about $46,000 a year. Dementia-related drugs cost around $27,000 a year, so our goal is to strengthen the memory in dementia patients and help reduce financial stress and improve quality of life in this low-income elderly community. The NeuroCleanse patch addresses the grand challenge of reverse engineering the brain. It relies on understanding how neurons exchange information and uses electromagnetic waves to stimulate nerve growth and delay dementia. It shows how technology and neuroscience can repair brain functions and improve cognitive health.
Ultrasound stimulation devices are being used for current medical research to stimulate brain regions. These are being used to study treatments for Alzheimer's, Parkinson's, and depression by enhancing brain activity and improving waste clearance. Also, rechargeable microbatteries exist, which would be used to make sure that the patch can run the low-power ultrasound and EEG sensors safely during long times. The EEG sensors are often used to record and monitor brainwave patterns in real time. Our NeuroCleanse patch would use this technology to track gamma wave activity and adjust stimulation for ideal results.
We also looked at whether this is practical. Funding could come from groups like the National Institute on Aging or foundations focused on brain health. Overall, developing the patch from research to trials and approvals might cost between $40 to $75 million. Some of the main challenges are making sure people use the patch consistently and getting government approval. We plan to make it simple and comfortable, and our strong clinical trials will show that. Patients would pay around $6,000 once for the reusable electronics with small monthly costs for replacement parts, and using the patch could save over $20,000 per year compared to traditional drug therapies, and insurance could also help cover the cost.
Even with our high-quality micro batteries, continuous nighttime use requires a lot of power. Convenience would be reduced for users if they have to keep recharging the batteries. Continuous use of a bioadhesive patch for long periods might cause skin irritation, sweating, or discomfort, especially for elderly users with sensitive skin. Even though there is research that supports the gamma wave stimulation and lymphatic system activity, there isn't strong evidence that wearable ultrasound stimulations can safely or even effectively improve brain toxin clearance in humans. Further clinical research is needed to provide the effectiveness and safety.
So our next steps and our immediate goal is to create a working prototype that tests whether gentle electromagnetic stimulation can help the brain clear waste during sleep. To do this, we'll track brain activity through EEG, which, by the way, it's a test that measures the electrical activity of the brain, alongside heart rate, breathing, and movement. After we have a prototype, we'll run a small pilot study with volunteers to see how comfortable it is, ensuring it's safe, and look for early signs that it's actually helping the brain's natural cleansing process. At the same time, we'll put together all the necessary documentation to meet ethical and safety standards, and these steps will give us the insights we need before moving on to larger studies.